This is our inequalities review for Math 6. So this video will cover writing word sentences as inequalities, graphing inequalities, as well as solving all one-step inequalities using all four operations. So let's go ahead and get started. And as a quick reminder, remember for all these videos, I highly suggest you pause the video once you see the math problem, try it on your own, and then restart this video to check your work. So our first slide says to write the word sentence as an inequality. So here we're going to find the words and phrases that tell us the operation that's being done, as well as the inequality sign that's being used. So our first sentence says, a number x increased by 5 is greater than 8. So here I'm going to underline the phrase increased by, and that tells us it's addition. And then we also have this phrase greater than, and that's our inequality sign, the greater than symbol. So if we were to translate this sentence into an inequality, it would be x plus 5 is greater than 8. Here we're not solving, we're just writing them as inequalities. Our second one says twice a number k is at least 14. We have this word twice. That means we're multiplying, but we're not just multiplying, we're multiplying by 2. We're going to take a value and have twice that value, we're multiplying it by 2. We're doubling it. And then at least is saying 14 is the minimum, so it's greater than or equal to. So twice the number k is 2 multiplied by k is at least, so greater than or equal to 14. Our next slide says to tell whether the given value is a solution. So here we're doing some check step type work. We're going to be plugging in the value that we're given and seeing if that value makes our inequality true. So our first one says 2n is greater than 16 when n is equal to 9. So here we have to take our value of n and plug that in. So we're going to rewrite this. 2 multiplied by 9 is greater than 16. Now we actually have to do this math here. 2 multiplied by 9. We get 18 is greater than 16, which we know is not true. So our answer here is no. N equaling 9 is not a possible solution for this inequality. Our second problem says x minus 1 is less than or equal to 9 when x equals 10. So again, I'm going to take that value, plug it in for my variable. So I've got 10 minus 1 is less than or equal to 9. Again, I have to do the math on the left here. 10 minus 1 is 9. Is 9 less than or equal to 9? It is equal to, so this is yes. X equaling 10 is a possible solution for this inequality. Remember, you need to plug in, do the math, and then answer yes or no. Here, we're just going to be practicing graphing our inequalities. So this is where open circle versus closed circle comes in and deciding which way we point our arrow. So we've got y is greater than 4. So I'm going to draw a quick number line. I like to put 0 in the middle. I put the number I'm graphing and then its opposite, so -4 here. Our inequality sign is greater than. So y cannot equal 4, which makes our circle open. And then we need values for y that are greater than 4. So all numbers that are greater than 4 are to the right on our number line. So now we've graphed y is greater than 4. Our second inequality is m is less than or equal to 11. So again, I'm going to make a very quick number line with 0 in the middle, my number and its opposite, so 11 and -11. Because we have this or equal to piece, the value of m is allowed to be 11. So because 11 is a possible solution, we actually put a closed circle when we're graphing on this number line. And then we need other numbers that are less than 11. So smaller than 11, we are going to shade to the left. So really make sure you're paying attention. Are you having an open circle versus a closed circle? Meaning, can your value equal the variable or not? And then our arrows pointing in the direction where all possible solutions for your variable exist. So numbers that are greater than 4 are to the right. Numbers that are less than or equal to 11 are to the left on this number line. Let's go ahead and keep going. Here we need to solve and graph. So these are going to be one-step inequalities. And then once we find our answer, we're going to put that on a number line. So we've got x plus 4 is less than or equal to 8. I'm going to draw my railroad tracks. To get rid of this plus 4, I'm going to subtract 4 from both sides. That gets rid of my 4, and I'm left with x is less than or equal to 4. And there is my answer. So now I need to put this on a number line. So again, we get a lot of practice with our number lines here. Because we have this or equal to piece, x can be 4. So I'm coloring my dot on 4. My circle is closed. And then numbers that are less than 4 are to the left on this number line. Our next problem is g minus 16 is greater than 8. So I need to get rid of this subtracting 16 by adding 16. And remember, you have to do this to both sides to keep that even. So we've got g is greater than, and I need to find the sum, 16 and 8, which is 24. So I've got g is greater than 24. And now I need to put that on a number line. So I'm going to have 0, 24 to the right, negative 24 to the left. Here, g has to be greater than 24. G cannot equal 24, so I'm going to keep that circle open. And then numbers that are greater than 24 are to the right. So let's go ahead and continue on with solving and graphing. 121 is greater than or equal to 11s. So when I've got my number and my variable right next to each other, that is multiplication. So I need to divide to get s by itself. So I'm dividing by 11. I'm left with s. Bring down my inequality sign, and then 121 divided by 11 is 11. Now here, this one looks a little bit different because our variable is on the right side of our inequality instead of the left. My number line is still going to be the value I'm plotting, and then it's opposite, so 11 and negative 11. S is allowed to be 11 because of this equal to piece, so it is going to be a closed circle. But now I need to figure out what number makes this inequality true. 11 is greater than or equal to what number? So I can plug in a value. 11 is greater than or equal to 0. So because that's true, and I just randomly picked a number 0, I chose 0 here to see if it worked. 11 is greater than 0. So because that's a possible solution, I point my arrow to the left. And those are where all my possible solutions for this variable are located. Our last solving problem. Here, it's originally a division problem. We've got x over 3, which is division, is less than 15. So in order to undo this division, we have to multiply. And we're going to multiply both sides by 3. We can cancel our 3's out on the left. We've got x is less than 45. Again, we need to now put this on a number line. So our number lines don't have to be extremely detailed and perfect. I just need to get a general idea of what we are counting by on the number line. So here I've got negative 45 and 45. Because x has to be less than 45, it cannot equal 45. So it's an open circle. And then numbers that are less than 45 on this number line are to the left. So I'm going to point my arrow again towards the left. Our next slide says to write the inequality and solve it. So we're not graphing here, we're just translating an inequality from a sentence and then solving it. So we've got 2 less than a number x is more than 15. So less than is subtraction, and then this more than is my inequality sign. So I'm taking 2 less than x. Less than is that turnaround phrase, that turnaround words. So it's x minus 2 is greater than 15. So I've written my inequality. Now I have to solve it. So this is a subtraction problem, so I need to use addition. I'm going to add 2 to both sides, and I've got x is greater than 17. I do not need to put this one on a number line. Our directions don't tell us to, so we're just going to leave that as is. Our next problem says 3 times the number x is more than 18. So 3 times is we're multiplying here by 3. A number x is more than, so a greater than symbol there. So 3 times the number x would be 3x. More than is that greater than symbol, 18. So I've got 3x is greater than 18. This is a multiplication problem. So in order to get x by itself, I have to divide. And here I'm dividing by 3 on both sides. And I've got x is greater than 6. Again, no number line needed. So that is our final answer there. Our last slide for this video is a word problem. It says you are selling pizzas for your choir class. Each pizza costs $6. You have to raise at least $84 to win a prize. Write and solve an inequality that represents how many pizzas you have to sell to win a prize. So I like to read through the problem and then I go back and underline, circle, or squiggle underneath important information. So it says each pizza costs $6. So every pizza is $6 a piece. You have to raise at least $84. So at least is like minimum, so greater than or equal to $84 to win this prize. Write and solve an inequality that represents how many pizzas. We don't know how many pizzas. So I'm going to use the variable p for the number of pizzas. What I do know is every pizza, so p pizzas, cost $6 a piece. So it's 6 times however many pizzas I sell, so 6 times p, needs to be at least, so greater than or equal to $84. So we need to figure out how many $6 pizzas I need to sell in order to get minimum $84. So here's 6 multiplied by p. I need to divide. So I'm going to divide both sides by 6. I've got p left on its own and then greater than or equal to. Now here, I may not know exactly how many times 6 can go into 84. So I can do a quick little long division problem. So 6 can go into 8 one time. I bring down my 4. 6 goes into 24 4 times. And I've got no remainder. So 84 divided by 6 is 14. So what this means is we need to sell at least 14 pizzas. So if we sell at least 14 pizzas, we'll be able to win this prize. So that concludes our video over inequalities. Please feel free to rewatch any section you need extra practice on. Look over old graded homework, study your class notes, and good luck studying.